Alright, so this week we're going to take a look at two sections, okay, 4.2 and 4.3. We're going to split 4.2 into 2 days. We'll do half today, half tomorrow. 4.3 we'll do on Wednesday, and then Thursday will be a review day. Alright, so as I said earlier, the idea here is we're going to go back to solving triangles. Okay, we're going to find the sides, find the angles. But we're going to look at it where we have the case where we don't have a 90-degree angle. Okay. If a problem happens to come up this week where you do have a 90-degree angle, you can solve it like you did 2 weeks ago. Or you can solve it with what I'm teaching you this week. Okay. The nice thing about the law of sines, and what we're going to learn on Wednesday, the law of cosines, is they work for any triangle. Okay. Where something like the Pythagorean theorem or the SOHCAHTOA idea, bless you, that doesn't work, bless you, okay, for any triangle. Okay, those two things only work for right triangles. Okay, so you're learning something a little bit more, it's kind of universal. You can use what we're learning this week in more cases. Okay. So if none of the angles in a triangle are 90, okay, you have what's called an oblique triangle. And under oblique, that kind of falls into two categories. You can have a triangle where all the angles are less than 90. Okay, think of like an equilateral triangle. That's one case of what we call an acute triangle. Or you could have one angle in a triangle that's obtuse, and that's an obtuse triangle. Okay, so both obtuse and acute are what we call oblique. So I said you could have one angle in a triangle that's obtuse. Could you have two angles in a triangle that's obtuse? Two obtuse angles. Mom?
No.
No, how come? Obtuse is greater than 90, yeah. And what would happen if you had two angles that were both greater than 90? Right, all the angles have to add to 180, okay? So you can only have one angle at most that's obtuse. Okay, so when we solve triangles, what we usually do is we label it with certain letters. Okay, we've seen A, B, and C for the sides before, and we're still going to use that same idea. Just remember that C isn't necessarily the longest side. Okay, it doesn't really matter how you label the sides, but then it's where you put the angle names in relation to the sides. So you always want to put alpha across from A. Okay, wherever you put A, put alpha across from it. Wherever you put B, does anybody remember the name of that Greek letter? Yep, beta. So B is always across from beta. And this Greek letter is new. Okay, we never used a Greek letter there because that was always the 90. So we didn't have to label it. Well, now it's not 90. So we got to give it a name. So C is always across from, does anybody know that Greek letter? It's gamma. So A across from alpha, B across from beta. I think those two are kind of easy to remember. And then if you can just remember the name or what it looks like, the third one is gamma. Now, some books, they don't do it with English letters and Greek letters. They just use all English letters. What do you think could be confusing if, let's say, they use lowercase letters for the sides and capital letters for the angles? What could be confusing if you do it that way? Oh, Rudy, any thought? Well, if you use like lowercase letters for the sides and capital English letters for the angles? Not sure. Anyone have a thought? What might be confusing when you write it on paper? Yeah, Ashley?
Some people's handwritings are kind of like all caps, so there's that problem. And then there's like, if you write it down, like you have to write lowercase a for all the time for that one. What would you say? Like lowercase a would end up being like the side of the angle, so you have to have, you write it out like, I don't know, it's hard to explain. Like, I know what I'm trying to say in my head, but it's just not coming out.
Okay, well, that's all right, give it a shot. I think C is a kind of a confusing letter because I think a capital C and a lowercase c looks the same, unless you have context with other letters around it to determine is it capital or lowercase. Like that one right there, you can't really tell. Is it capital or lowercase? So that's one problem. And the other problem is if I ask you a question or you ask me a question and you say, what's A? Well, if we're doing capital and lowercase, then we have to say, well, do you mean capital A or do you mean lowercase a? If you use Greek letters and you say, what's alpha? There's no confusion. I know you're talking about an angle. If you say, what's A? I know you're talking about a side. All right, so I think it just makes it less confusing to do it that way. All right, so we're going to solve triangles in two different situations today. Well, two kind of big categories, but one of those categories can be broken down a little bit. So the first case that you would use what we're going to learn today is if in the original problem they give you two angles and a side. Okay, let me just go ahead and show you an example. That's a problem that you would use what we're learning today. They're telling me alpha, they're telling me beta, there's two angles, and they gave me a side. But there's a couple ways that they can give you two angles and a side. Here's two different cases where in both of them you're being given two angles and one side. Okay, the difference is that in the first one, they're giving you two angles and the side that's between them. Okay, think of it as the side that's connecting these two angles. Okay, that's ASA. Versus SAA, they're giving you two angles and a side, but they're giving you a side that doesn't connect the two angles. So you have an angle, and they're not giving you the bottom side. Okay, if they gave you the bottom, that would be the first case. You'd know the side that connects the two angles. They're giving you one of the other two sides. Right, so it's just the placement of the side. Is the side between the two angles or not between the two angles? And you can write these forwards or backwards. If you write AAS when we're talking about something, that's fine. ASA, obviously the same, forwards and backwards. Okay, so that's one case we'll look at. Two angles and a side case. Okay, and the other case we'll look at partially today, we're going to wrap up with one of these, but we're going to continue looking at it tomorrow, is the side-side angle case. Okay, this is where they're giving you two sides and an angle. And specifically, the angle that they give you is not between the two sides. So here's the angle they gave you. And it is not the angle that's formed by the two sides that are given. If they gave you this angle right here, that would be a side, angle, side. That's a different problem. Okay, you can't solve that with what we're learning today and tomorrow. Okay, so if they give you two sides for today and tomorrow, they cannot give you the angle that's where the two sides meet. It has to be outside of the two sides. This abbreviation, I'd prefer if you put it in that order. It's not nice if you write it the other way. So. All right. Any questions on that one? All right. So, how are we going to solve this? So to solve any of the three types of problems I just mentioned, you're going to use the law of sines. Okay, so we're going to take a look at where the law of sines come from. It's actually very simple to describe where it comes from, just using the SOHCAHTOA stuff we learned a couple weeks ago. Okay, and the way this law works is there's really three parts to it, or three fractions. We're going to look at where two of the parts come from, and then I think you'll see where the third part is going to come from, because you'll see a pattern. All right, so I'm going to show you where the law comes from. So if you want to leave a couple lines, you'll be able to fill in what the law is in a second. But right below that, I would put this diagram. But leave a couple lines. All right, so start by drawing a triangle. Okay, just a scaling triangle. None of the sides should really look the same. And then once you draw that triangle, you only need to label 2 of the sides and 2 of the angles because I'm not going to be using the third angle and the third side for what I'm going to do. But what I am going to do is put a vertical line in from that vertex perpendicular to the bottom side. Okay, so now by drawing that original triangle and putting in that vertical, what did I just create? What kind of triangles did I just create?
Right triangles.
Yeah, I created 2 right triangles. That line that you drew in from the top to the bottom, just call it the, well, h could be confused with hypotenuse, but in this case, h is height. Okay, so don't confuse that with hypotenuse. Questions on the diagram? All right, now what I'm going to do is I'm going to look at this as 2 separate problems. Okay, I'm going to block out the triangle on the right for now. Just look at the one on the left. Okay, I want to come up with a formula for the height. Okay, I'm going to use that angle, the height, and that side. So first thing I want to do is just figure out the names of the 2 sides from the perspective of that angle. So if you were standing right there. Connor, what's the side that's furthest away from the angle called?
Opposite.
Yep, opposite. And what about the angle that's, what about the side that's across from the 90-degree angle?
Adjacent.
The hypotenuse, right? The one that's always across from the 90 is the hypotenuse. Okay, so he said that H is opposite, B is hypotenuse. All right, so Haley, what trig function involves those 2 sides?
Sine.
Yeah, sine. So we're going to start out by writing sine of alpha equals, and then Eric, what would go on the other side? What's the opposite side again?
H.
H. And the hypotenuse?
B.
B. Okay, so now I almost have a formula for H. I just need to get the B on the other side. So Emily, how do I move the B over to the other side?
Multiply it.
Yeah, multiply by B. Multiply by B. And there's a formula for H. The height of that triangle is B times sine of alpha. Okay, and I'll call that box 1. Any questions on that? Okay, for now, we're going to forget about that box, but we're going to come back to it in a minute. Okay, now what I'm going to do is I'm going to kind of block off the other side. And I'm going to do the same thing with that triangle. Okay, so the important thing to notice here is H is shared. H is in both of the triangles, the one on the left and the one on the right. And that's kind of the key. All right, so now I want to find a formula for the height again, but this time I'm going to use that angle and that angle. So I'm finding the same height, but now I'm using different information. Okay. So Irene, what would be the name of the side that's across from beta?
Opposite.
Opposite. And A would be?
Opposite. Oh, sorry, hypotenuse.
Hypotenuse. So it's the same names we used last time, so we're going to use sine. Again. And Emily, sine is opposite over hypotenuse, so in this case, what would go on the other side?
H over A.
Yep, H over A. And Connor, how would I get H by itself there?
By A.
Perfect. I'm going to multiply both sides by A. That's gone. Now, have another formula, which I'll call box 2, for calculating the height. Okay, so now let's look at both of them. Box 1 is a formula that calculates the height. Box 2 is a formula that calculates the height. So what do we know about box 1 and box 2? Yeah, Alex?
They're both hypotenuse times the sine of the opposite angle equaling the height.
Okay, so can you just say the last part again? They both equal the what?
Height.
Right, box 1 equals height, box 2 equals height. So what else does that mean about box 1 and box 2?
They both are getting the height the same way.
Well, they're getting the height different ways, right? They're each calculating the same thing 2 different ways. So but they each calculate the same thing. So how does box 1, excuse me, compare to box 2? Yes. That's the key. If box 1 and box 2 are calculating the same thing, then they are equal to each other. So B sine alpha equals A sine beta. Okay, and now what I'd like to do is just rearrange it so that it looks like what the law of sine is supposed to look like. Usually you put the A over with alpha, and you put the B over with beta. So how about, Zach, how would I move A over to the left side? Well, it's multiplied right now, right? I just didn't put the dot there. It's A times sine beta. Yeah, divide. What would you divide by?
Sine B.
So B is over on the other side. We're going to leave that. We'll come back to B. Can anyone else help him out? How do you move A to the other side? Yeah. Right, divide by A. Anytime you want to move something that's multiplied, you use the opposite operation. Just divide by it. And now how would we move B so that it's over with beta? Well, Pat?
Divide by B.
Yeah, divide by B. So what that's going to do is cancel the B's, cancel the A's, and now you pretty much have the first 2 parts of the law of sine. So you have sine of alpha over A. So this is where I told you to leave a couple of lines. You could put that in right there. Sine of alpha over A equals sine of beta over B. And that's the 2 parts we did. But there's one more fraction. There's a third fraction. And based on the pattern, does anyone think they know what the third fraction would be without going through the whole thing? Yeah?
The sine of gamma over c.
Yeah, perfect. Sine of gamma over c. So those are the 3 parts to the law of sine. It's 3 fractions. Sometimes you see it written with all of these flipped. You can write it that way. A over sine alpha, B over sine beta. I don't write it that way. I put the sine in the top. Right, and kind of some general ideas about this formula. You never use all 3 parts at the same time. You're either going to use the first 2 parts, the last 2 parts, or the first part with the last part. Okay? But you only use 2 parts at a time. And all of these fractions are equal to each other. Okay? They're all equal to each other. So when we set up a problem, a lot of time it's going to look like this. You're going to set up a proportion. Okay? You're going to pick one of the fractions I just showed you to use. You're going to pick another fraction to use. And hopefully, if you pick the right fractions, 3 out of 4 of these spots are going to be filled in with numbers. There'll be one spot that has a variable, and then we just solve it the way you solve a proportion. Right, so one thing I think that's helpful here is if they don't give you a diagram to sketch it, because you got to figure out what kind of triangle do you have. You know, is it side-side angle, angle-angle side, side-angle side, side-side-side? Okay, a couple there I didn't talk about today, and we won't till Wednesday. But you got to figure out what type of triangle it is, and then once you know that, you decide, okay, I'm going to use law of sines, or I'm going to use law of cosines. If you pick the wrong law, it won't work. It won't work. So we'll make a sketch, and then we'll put everything in a table. And I generally put boxes around the three things I need to find in the table. Okay, you can still use the facts that all the angles in the triangle add up to 180. That's still true. But, and we said this earlier, if you don't have a 90-degree angle, which theorem is out the window? Can't use it anymore. Yeah, the Pythagorean theorem. Okay, forget about Pythagorean theorem if you don't have a 90. And if you don't know what the angle is, don't use Pythagorean theorem either, because then you're assuming the answer is 90 when it might not be. Okay, so don't use Pythagorean theorem unless you know you have a 90. Okay, so we'll look at 3 problems. We'll do one of each type I showed you, and that'll be it. Okay, so the table I've already set up for you. Put the 3 sides in one column, 3 angles in the other. And I think before I even start it, I'm just going to make a sketch. Okay, I'm going to put everything that I know in a diagram. Mason, does it matter where I put A, B, and C? No, there's no restriction on where I put A, B, and C. I put them anywhere I want. Bless you. Okay, but now you have to put the angles in certain spots. Okay, once you've decided where to put the sides, the angles go across from the appropriate side. So A, I'm going to make that 4. B, I don't know. C, I don't know. Beta, it's going to go across from B. And alpha, it's going to be across from A. And that's gamma, because it's across from C. Okay, let me try to sketch like a really nice looking gamma. My gammas usually get worse as I go on. But that's what it kind of looks like. It's supposed to look kind of like a Y, sort of.
Oh, it's like an Aries symbol.
Yeah, that's what it kind of looks like. All right, so let's look at what we're given. Angle, another angle, and a side. Okay, so Orion, is the side that I know the one that connects the 2 angles?
No.
No, what's the side that connects the 2 angles? What's that one labeled?
C.
C. Okay, so this is the one where the side is not between the 2 angles. So that is this one. The side is not between the 2 A's. Side, angle, angle, or you can put angle, angle, side. Okay, so now the first thing I would do is go back, if I need to, look at my reference sheet and decide, is that one of the types that I use law of sines? Yes, it is. Okay. Side angle angle. Wait, anybody see something there we could find relatively quickly? Maybe we don't even need what I taught you today to do this. Yeah.
Gamma.
Yeah, gamma. What's gamma?
80 degrees.
It's 80 degrees. All right. Now last week, once we found this 80, What did I say about using it to find other things? Don't. How come? I could be wrong. And that works fine in a right triangle. In this kind of problem, you are going to have to use gamma to find C. You have no choice. So if you get gamma wrong, C is automatically wrong as well. Okay, there's no way around it. You could still get B right. Okay, so B is totally separate. So you could still get that right, but if you get gamma wrong, you're going to get C wrong as well. All right, so now we'll set up our law of sines. Let's do B first. Okay, so anytime you use the law of sines, you want to start with the row that has everything in it. Katie, do I have a row in the table with everything in it?
Alpha and A.
Yeah, the first row right here. In fact, that's a hint in general that you can use law of sines. If you didn't make a diagram and all you made was the table, if you have a row with everything in it, that's a law of sines problem. Okay. And you might, well, if you're thinking, well, how could you have a problem without a row with everything in it? If I gave you a side, 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 you would not have a row with everything in it. Okay. And you couldn't solve it with what I'm teaching you. Okay, so that's another way to tell it's a law of sines problem. Okay, so let's start with the top row. Let's go back and look at the formula that has the part of it that has the A and the alpha. Sine of alpha divided by A. So sine of 40 divided by 4 equals. And now if we're finding B, we're going to go back, look at the part of the law of sines that has B. That's the second part, and fill in everything you can. Sine of beta divided by B. Well, I know beta, so sine of 60. And I'm looking at that, and I see a number, number, number. So the last thing has to be my letter, and it is because I don't know B. And now solve for B. Does anyone remember how you solve a proportion? What do you do? Okay, you cross multiply. Now, for the first one, I'll do all the steps out with cross multiplying, but if you can do this in your head and get B by itself, that's fine too. We don't use a calculator till the last step. All right, so we have 4 sine 60 equals B sine 40. Okay, and Connor, how would I get B by itself there? Dividing by? Well, B we want to leave alone, so we don't want to do anything to B. We want to move everything that's not a B away from it.
Divide by sine 40.
Yeah, divide by the sine of 40. What is the sine of 40? I don't know, and I'm never going to find out. Okay. All I want to know is that whole calculation. So I'm going to type that into my calculator and round it off. All right. So looking at my calculator before I even type this in, what should I fix? There's something about it that it's not set up, and if I type it in right now, it's going to be wrong.
You're in radians.
I'm in radians. Every problem this week is going to be in degrees. It's not that you can't do these problems in radians. You can do them in any measurement you want. But we're just going to stick with degrees. 4 sine 60. It's important I close that parenthesis if I'm going to type everything in at the same time. Divided by sine of 40. Not as important that I close the parenthesis on the end because there's nothing else coming after it, but I like to close it. Okay, so we get 5.38 now. Okay, so that's B. Okay, so we got 5 out of 6 things. We have one thing left to find, which is C. How about Rudy, can I find C using the Pythagorean theorem? No, how come?
Because B could be wrong.
Okay, B could be wrong. Is there another reason? And it's rounded. Is there another reason why you might not want to use Pythagorean theorem?
It's not a right triangle.
Exactly. You can't use it here. It's not a right triangle. So if you use Pythagorean theorem, it's definitely going to be wrong because gamma is not 90. It's 80. Okay. Right. So now we'll find C. Now, technically, you have a choice of which rows you can use. You've got to pick a row with everything in it. Robin, which row do you think I should use? Row A or row B?
Probably row B.
Yeah, how come?
Because the B you have is rounded, so it's probably not right.
Right. At least if I made a mistake finding B, I don't have to use it to find C. Okay. So let's go back to what we were given. So we're going to do sine of alpha over A. So sine of 40 over 4. And now we're going to find C. Anyone think they can tell me what's going to go on the other side of that proportion? Sine of what over what? Emily?
Sine of 80 over C.
Exactly. Sine of 80 over C. Right, and now when I do the cross multiply, I normally don't write out this step kind of in the middle. What I do is I know that C is going to equal 4 sine 80 divided by sine 40. Because you'd have to cross multiply, and then C would be next to sine 40, and you'd have to move it to the other side. If you don't like it that way, you can show out the cross multiplying every time. But if you just show that on the test, that's fine too. And that's it. That's C. Any questions on how I got C by itself? Since I didn't show out the cross multiplying. Okay, so let's type it in and see what we got. Okay, if on your calculator you can bring up the last thing you typed in, a lot of times you can pretty much type the same thing in again and just change one number, so kind of speeds it up. So this time I just have to change it from 4 sine 60 to 4 sine 80. Okay, other than that, the calculation is the same. 6.128. Okay, a couple things you can check quickly. Make sure the biggest side is across from the biggest angle. Yep, looks like that happens here. Make sure the smallest side is with the smallest angle. And make sure that when you add any two sides together, they're bigger than the third. Right, so like if you add 4 and 5.3, you get 9.3, that's bigger. If you add B and C, that's bigger than A, and so on. If you add two sides together and they're not bigger than the third, then something's definitely wrong. Or if the biggest side isn't with the biggest angle, smallest side with the smallest angle, something's wrong. Okay, so everything looks reasonable here. It doesn't guarantee it's right, but to me it doesn't look like there's anything definitely wrong with it. And that's a side angle angle. Okay. Any questions on side angle angle? All right, so notice in this problem, you already had a row that was complete. Okay. Let's look at this one. Okay, so this time I've already sketched it for you. And the first thing I want to do is just identify what type of triangle this is, using the three letters, like SAS, SSS, what kind of triangle is it? Anyone think they can tell me the type of triangle this one is? Ready?
Sine angle, sine, angle, sine, angle.
Yes, this is angle, side, angle. Different than the last one because this time the side that you know connects the two angles. Okay, so angle, side, angle. I go back to my notes and I look, yep, angle, side, angle is a problem that you use log sides with. Okay, but I said to you, you have to have a row that has everything in it in the table to use law of sines. The way it's written right now, do I have a row with everything in it? Emma? No. But can I find something and then I will have a row with everything in it? Oh, Matt?
Gamma?
Yeah, I can find gamma. And then I will have a row with everything in it. Can you tell me what gamma would be?
75.
Well, let's add those first. What's 45 and 40?
85.
85. And then subtract 85 from 180. 95. Yep. Now you have a row with everything in it. Why do you think it's really, really important that you get gamma right in this problem? Right, because now you're going to use gamma to find B, because you're going to use the row with everything in it to find B, and you're going to use the row with everything in it to find A. So in this problem, if you get gamma wrong, everything's wrong. Okay? And there's no way around it. You have to use gamma. Okay? Okay, so take a few minutes and see if you can at least set up your proportions to find A, and then find B, and then we'll go through it together. Okay, but if you get stuck, just call me over and I'll come help you out. All right, so let's see if we can set up our proportions to find A and B. How about Connor? Which proportion did you set up first?
One for B.
B, okay. Let's set that up. Can you tell me the proportion you had to find B?
Sine of 40 over B equals sine of 95 over 4.
Perfect. Sine of 40 over B equals sine of 95 over 4. Now, did anybody have it switched? Like they had the sine 95 over 4 on the left and the sine of 40 over B on the right? Yep, that's fine too. The only thing that really matters is when you cross multiply, B should be on the diagonal with sine 95, 4 should be on the diagonal with sine 40. Okay. So we'll cross multiply now, get B by itself. So Alex, when you solve for B, it's going to be what times what divided by what?
B 4 sine 40 divided by sine 95.
Perfect. Sine 95. And now just type that in. Okay. Does anybody have the answer to that? They already typed it in? Yep.
I got 2.5.
2.581.
581.
Okay. Did anybody else that had a calculator get 2.581? Yep. Okay, good. Okay, so now we've got B. Okay. I don't know A yet, but I can tell you it's going to be pretty close to 2.581. Does anybody know how I know that? Yeah.
Because their angles are alike.
Yeah, alpha and beta are pretty close. It's almost isosceles. And in fact, if alpha was 40, then I would already know the answer to A. Okay, so I could use that to help me out. If you've got two angles that are the same, you're going to have two sides that are the same. So keep that in mind in case that ever happens. But they're not quite the same. Alpha's a little bigger, so A is going to be a little bigger. All right, so Molly, did you get your proportion set up to solve for A? All right, can you tell me what row would you definitely have to use to find A? You've got to use row C. It's the only row with everything in it. So just to set it up the way we did on the other side, I'll put that on the right. And can you tell me, Molly, what would go on the left-hand side of that proportion? Yep. over, yes. Okay, so cross multiply just like we did before. And A is going to be 4 sine 45 over sine 95. All right, and anybody already have that as a decimal? Yeah.
2.839.
2.839. Okay, it looks reasonable. It's a little bit bigger than B. Alpha's a little bit bigger than beta. But looks reasonable. What you can't do is if one angle is double the other angle, and you can't say, oh, then that side will be double the other side. Doesn't work that way. Okay, if one angle is double, the other side will be bigger, but it won't be double. Okay. So, any questions on that one? Okay, so that's the two types where you are given two angles and a side. Okay, two different ways that can happen. Okay, the third type, side-side angle. All right, so here's a diagram of side-side angle. Okay, we know that it's side-side angle because you have a side, you have a side, and the angle that they're giving you is not the one that's between the two sides. Alright, so here you got to be careful because when you have side-side angle, there's three things that could happen. And so far, in the other kind of problems we've done, pretty much only one thing that happens. You solve it, you get one answer. That's it. Well, this problem could work out to be just like the other ones, where you solve it and you get one answer. Or, when we start to solve it, we could get two answers. Or we might figure out that this is impossible and there's no solution. So today we'll look at one of these three cases, and then tomorrow we'll pick up with the other two. Okay, so let's start to solve it and see what happens. And I think you'll know pretty quickly, or you'll notice something that's different about this than the other two problems. Okay, so there's all our information in a table. Okay. Did anybody notice something that is different here? Something you can't do that we could do on the other two? Alex?
You don't know what the sign of what you're trying to find yet is for the second part of the equation. You just know what it's going to be divided by.
All right, so we don't know the angle, right? We can't just add two angles up and get that third angle. There's no way to do that because we only have one angle. So, what do you think we have to find first? Excuse me. We have no choice. We have to find this first. Yeah.
I think we can do Pythagorean theorem on these because they have both the sides.
So you think we could do Pythagorean theorem to find the hypotenuse? Does anybody have any thoughts on that? Whether or not we could use Pythagorean theorem? Yeah.
We don't know if it's a right angle.
Right. If we use Pythagorean theorem, then we're assuming that that's a 90. Maybe it is, maybe it isn't. We don't know. But we can't assume it is. All right, so it's a good guess, and that's exactly what we did in the problems 2 weeks ago. We could use Pythagorean theorem at this point. All right, so anybody know what I have to find first? I have a choice of beta, C, and gamma. Alex?
Beta.
You have to do beta first. There's no way you're going to be able to get C or gamma because that row is empty. You have nothing in that row to help you at all. So until you get something in that row, you can't use it. So we've got to do beta first. Okay, so let's set up our law of sines to find beta. Okay, so we're going to start like normal. sine of an angle, divide by what's across from it. And then set up the other side. Sine of an angle, divide by what's across from it. So sine of beta over 2. Now when you look at that, what do you notice about where the variable is compared to where it's been in every other problem? Yeah, it's in the sine function. Okay, the variable is in the sine function. It's not next to it, it's in it. Okay, it's kind of like, it's like this. I would say the variable is in the square root function. It's inside it. Okay. So let's cross multiply and see what we can do. So we've got 2 sine 40 equals 3 sine beta. And remember, my goal is to get beta by itself. There's 2 things preventing it from being by itself. The 3, and then the function that it's within. Let's start by getting rid of the 3. Okay, Eric, how can I get rid of the 3?
Divide.
Yep, by
3.
divide by 3. Okay. So now I have 2 sine 40 over 3 equals the sine of beta. And that beta, it's inside the sine function. So when you have something that's in a function, you can't cancel it with add, subtract, multiply, or divide. The only way you can cancel a function is with another function that's the opposite of it. Does anybody remember what we can use to cancel out the sine function? You can't add, subtract, multiply, or divide because it's a function.
Is it sine of the cosine?
Okay, so we're on the right track. You're thinking of another function, but cosine doesn't cancel out sine. We got another one, Katie?
The inverse of sine?
The inverse sine. Exactly. So you're going to take the inverse sine of that whole side, and that's going to cancel. And then you're going to take the inverse sine of that whole side. And that is your answer for beta. That's gone. So beta is the inverse sine of 2 sine 40 over 3. Okay, so let's type it in. So now, when I type it in, if I get an error, either I type something wrong, or did a step wrong, or that means it's a no solution problem. Okay. So we've done everything right so far. So let's do inverse sine of 2 sine 40 divided by 3. Okay, so we've done all the steps right. We typed it in right. And I got an answer. So this is not a no solution problem. What that tells me is there's at least one solution, maybe even a second one. Okay. But I'm definitely going to write that one down. 25.374. And notice how I wrote it in that box. I wrote it up higher. So if there's a second solution, what I'll do is I'll write it right underneath it. Okay. So how do you check for the second solution? Take the answer that you just got. In this case, we solved for beta, but it could have been you solved for alpha or gamma. It depends on the problem. But the point is, take whatever you just got, subtract it from 180. Okay, let's start with that. So we got 25.374. So if there is a second answer to this problem, it's 180 minus 25.374. 154.626. I'm just going to write that. Actually, I think I already have it written down. But just in case, I'll write it down again. I'm not putting it in the box yet because I don't know if it works. Okay, but if there's a second answer, that's what it is. Now, what you want to do is look at the number you just got Go back up and look at the angle that was given to you. They gave us an angle to start. And see if it's possible to fit 154.626 and the given angle in the same triangle. And by fit, I mean it can't add up to more than 180. If it fits, then it's a second answer. If the given angle and the 154.626 is too big, then we can cross out the 154 and ignore it. So let's go back up. What was the angle that I was given in that problem? The 40. So I was given a 40-degree angle to start with, so I know that that's correct. Can you fit a 154-degree angle and a 40-degree angle in the same triangle? No. Zach, how come?
Because it equals more than 180.
Because it what?
Equals more than 180.
Yeah, it equals more than 180, right? It adds up to 194.626. So in this case, it's too big, and we can forget about it. Right, so that's what we just said. Right, so if there's another angle, it's 180 minus the one we got. It would be 154.626. But we had a 40-degree angle to start, so if you add together the two angles, it's greater than 180. It's too big. Okay, any questions on why the 154 doesn't work? Okay, so now because it doesn't work, we're just going to do this like a normal problem. Now that I know beta, what will that help me to find that I couldn't find when I was starting the problem? Gamma. Now I can get gamma because I have two of the angles. Just add them up and subtract from 180. So we have 180 minus 40 and 25 is 65.374. Now I finally have a piece of information in the last row. It's no longer empty. So 114.626. And now that I have gamma, what's the last thing that I can find? About C. So whenever you have a side-side angle problem, you have to do it in that order. Okay? Find the angle you're missing, then the other angle, then the side you're missing. Okay, so let's set it up so we can find C. Okay, got to use a row with everything in it. How about Faith? I've got two rows that have everything in them. Row A and row B. Which row should I use? Which one? B? How come?
Because it has everything.
Okay, so does row A though. So technically you could use either one of them. But any other reason why you picked B? There's something in row B that I think it makes it a little harder to use. Do you notice anything about beta compared to alpha?
It's rounded.
It's rounded, right? And it's a decimal. So what I would do is let's go back to the row that was given and use that. Okay, so we're going to start with sine of 40 over 3, just like we did right here. Okay, sine 40 over 3. And Emily, if I want to find C, I've got to use gamma. So how would I set up the other side?
And gamma.
Yeah. Well, to find C, you're going to use gamma. Gamma we know.
Would be sine 114 over C.
Yeah, sine of the 114.626 over C. And notice the variable, it's by itself. It's not inside the sine function, so you're not going to have to use inverse sine. Only time you have to use inverse sine is at the very first step. Okay, that's it. Okay, so cross multiply. And we're going to get c equals 3 sine 114. 0.626 divided by sine 40. Okay, so I'll just finish up by typing that in, see what I get. Okay, double check that you're still in degrees. Sometimes your calculator, or mine does, it resets itself back to radians, but I'm still in degrees, so that's good. Sine 114.626. Does it matter if I close the parenthesis? Yeah, if you don't close it, what it's going to do is this. 3 sine 114.626 over sine 40. If you don't close it, the calculator is going to think that's what you want to type in. And that's not quite what you want to type in. Okay? So just make sure you close it. So that sign is done. And now you're starting the new sign, 40. And that one, it doesn't matter if you close it because it's at the end. Okay, we get 4.243. Okay, so whenever you do one of these problems, you shouldn't use a calculator till the very last step. Okay. Don't round off like the sine of 40 and write that as a decimal. And then round, try to keep as much rounding as you can to a minimum. Just type in the whole thing all at once. All right, let's see, biggest side, biggest angle. Smallest side is the smallest angle. And any two sides added together look bigger than the other. Okay. So that's the side-side angle case. This is the only case all week where you have to check for the second answer. Nothing we did before this, nothing we're going to do after this, you ever have to do that. This is the only case, side-side angle. Any questions? Okay, so the homework tonight, it's on 266. It's 9 through 13, 17 to 21, and 25. Just odds. Okay, just the odds.